everybody. Good morning. I see a lot of participants up on the board. Thank you. We're just doing a little math practice because guess what? Today is going to be the day we're going to jump into a little math in here. So make sure that if you have something, your cell phone, calculator, anything, if you don't have anything, Google Calculator would be the best thing to have that tabbed up. But we are going to be jumping into a little bit of math today. So let me get the last few people in class here. And then we will jump into this and and boop. All right. Good morning, Angelina and Johnny. Yes, good morning. Good morning. All right. Let me just make sure we are good. I think we're good. Anaya, good morning. All right. So let's go ahead and jump in here. I'm going to close the door here. All right. So we're just going to grab your calculator, do some practice on our math. So we're looking at 20 divided by 5. And so again, how many times does 5 go into 20? When you punch it in the calculator, and this is where I see the most issues when we're dealing with calculators and stuff like this, always put the number in first. So you're going to go ahead and put in 20, then push the division sign, and then push 5, and you get the answer of 4. Excellent job. I see that up there. Perfect. I'm going to go ahead and give a good, nice check right there. Beautiful. So now over here, we're going to do 5 divided by 20. Again, 5 is going to go into the calculator first with the division sign. And as you look and as you know, that is going to be a decimal point, or we can put it into a fraction, but we'll just keep it as a decimal point here. And I agree with you, it's going to be 0.25. So beautiful job there. Now we're going to get into some integers here with negative and positive numbers. Remember, when you have a negative and a positive numbers, opposite signs, so that's a negative and a positive, then automatically your answer is going to be negative. Okay, doesn't matter what number it is on. If you have a negative and a positive, then your answer is going to be a negative when you are dividing. So when I say negative 12 divided by 6, so I can just go ahead and negative 12 divided by 6, put the 12 in first, you get a negative 2. I agree with you. Check on that one. Good. Let's do it the opposite way. 6 divided by a negative 12. Again, unlike signs, it doesn't matter what the negative number is on, as long as you know that the answer is always going to be negative. So 6 divided by 12 is going to be 0.5. Well, it's going to be a negative 0.5, so negative 0.5 right there. Nice job. Now, looking at this very last one here, you have 2 negative signs. 2 negative signs, so that's 2 like signs. Then your answer is always positive. It doesn't matter if there's 2 negatives or 2 positives. If there is like signs in both numbers, then your answer is always positive. So I'm going to go ahead and say 21, negative 21 divided by a negative 7, and I will get a positive 3. Okay, a positive 3. So nice job right there. Good job, everybody. So again, just wanted to kind of practice this because we will be doing a little bit of math today. All right, let's go ahead and jump into this. Now, before we jump in, I'm going to go ahead and give you your notes, notes in the chat box. Make sure as I go through the announcements that you open up those notes and raise your hand, because by the time I get to that part of the announcement section, you'll be ready to go and we won't have to waste our time with that. So go ahead and start opening up your notes and raising your hand. Remember, Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information or information of others into the chat box for your protection and the protection of others. Make sure you're respectful at all times and that you are participating and that you are school appropriate. All right, let's go. Let's jump into this. Looking at our schedule, I cannot believe it. We are on day 10 of 60. That means we are on Friday, December 10th. Can you believe it? December 10th. And we are moving into a new unit. So we are looking at unit 2 here. So intro to motion. This is a really kind of fun unit too. We're going to talk about motion, speed, velocity, all that good jazz here. And we're going to get really in the depths of our study here in physics and our physical science study here. So let's go ahead and jump in to see what we're going to talk about. But before we do that, I want to do an announcement here. Your Unit 1 airplane project is worth over 55% of your grade, so remember that. It was due yesterday, December 9th at 4 p.m. I will not zero it out until next week, so just kind of be aware. I'm going to be grading it just like it says at the, over the weekend, so either Saturday or Sunday. If I have some time tonight, I may jump into there and grade it, but that's when I'll be starting to grade it. By Monday, you should have them all graded, or whatever I have turned in, graded. Now remember, I want to show you this grading scale. It is a 5 to 10 grading scale as long as you provide a valid attempt. So here's the thing. You can get at least 50% or 50% of your points. This grading scale is an advantage to you. If you do give me a valid attempt where you actually, if I see you actually tried on this, you get 50% of the points for that particular slide. Let me tell you, 50% of the points is better than 0 points. You don't want to see double donuts. You want to see some points, right? And this is that Anaya, I'm so glad that you had some fun. So this is a really fun project. But what do I mean by a valid attempt? Well, I mean no blanks, no random answers. It should be clear that you watched the recording, that you went through every step, and that you gave it a good, honest try. Please make sure that you don't just send me a blank project. That is the biggest pet peeve of mine, is that when you send me just a blank project because you want it in, it's not going to do me any good, and it's not going to do you any good. I'm just going to shoot it right back, okay? So please do not send me a blank project, but if you do give a valid attempt, folks, you do get some points. So just kind of be aware that this grading scale is to your advantage, that you don't want to get 0 points. Some points are better than 0, okay? Let's just put it that way. All right. So as we move into Unit 2, Motion and Force, okay, that's what we're going to be talking about today. We're going to be talking a lot about Newton's laws of motion, friction, and gravity, and free fall momentum and collision. You're going to have your Unit 2 drop project. We finished one project. Now we jump into the next project. But if you look here, this isn't due until January 13th. That's like a month away. Okay, that's a month away. We do have winter break right in the middle of that. So again, that's an opportunity if you're bored to go ahead and do your project, playing out. So think about it. Again, let's see, I'll put the recordings up probably next Thursday for you for the Unit 2 drop project. Okay, so you don't really have to worry about it right now. Get that Unit 1 get that Unit 1 airplane project in, and then on Thursday, worry about your Unit 2. Okay. All right, today we're going to define motion and differentiate between speed and velocity. We're going to calculate velocity giving displacement and time, and we're going to do this all through our 2A notes. So we're going to be doing a little calculation today. That's why I asked, make sure you have a calculator. My good old pink calculator is always right by me. You will see this multiple times this trimester here, and good old pinky calculator. That's why I call it Calky. Get it ready. Yep. There are a couple of different options. Cell phone. Cell phones have calculators now. If you don't have a cell phone, just literally Google calculator. One will pop up for you. Okay? All right. So we're at that point of going ahead and opening up our notes. Your notes are up in the chat box. I will put them up one more time in the chat box for my late birds there coming in. And I will give everybody about 20 seconds to finish up getting their notes open with. Once you're done that, raise your hand. And if you are watching the recording, click the grades tab, scroll down to 2A notes, and start your quiz. 20 seconds up on the clock. Go, go, go. I see a lot of people that still need to open up their notes. Beautiful. One more second. Alrighty, so still looking for Alexis, Braden, Cantoya, Luis, Mario, and Peter. Peter, Mario, Luis, Cantoya, and thank you, Luis. Awesome. Peter, Mario, Cantoya, and Braden. Let's get 100% in this class. Woo! I love it. Braden, Cantoya. There we go. Cantoya and Mario, you're my last two. Let's get 100% up there. We are like 98% of participation. I love it. Makes me excited and makes me really kind of just all fun and games. All right, let's go. Thank you, everybody else. All right, so let's go ahead and take a look at this brain stretch. A car travels 88 miles in 1 hour. What is the speed of the car? What is the speed of the car? Who can tell me in the chat box? If a car travels 88 miles in 1 hour, what is the speed of the car? It's going 88 in a 50 zone. Yep, good job. Yeah. Let's get some more answers up there. I see it. It is. It's going 88 miles per hour. Now, this is just a challenge. This is just a fun thing. What movie is that from? This is just a fun little... Who knows what movie that's from? It's in the 80s. The movie's like from the 80s. Early 90s. Yes, good. Yes, it's from Back to the Future. Yes, Back to the Future. Yes. All right, and I saw Johnny up there kind of like, I don't get the question. I love how you asked that. So if a car travels 88 miles in 1 hour, so if I'm going 88 miles in 1 hour, then obviously my speed is going to be 88 miles per hour. Okay, miles per hour. So how you take that is, again, if we kind of convert it, if you look in there, mph, miles per hour, is going to be 88 because I'm going 88 miles in 1 hour. If I was going 50 miles in 1 hour, it would be 50 miles per hour. Okay, so same thing. All right, excellent, Johnny. Perfect. So if I'm going 88 miles per hour, like Doc Brown has asked us to do to make sure that the DeLorean gets into, space travel or time travel, if the car is traveling at this speed for 3 hours in total, how far will the car have gone in total? So if I have 88 miles per hour in 1 hour, how far will the car travel in 3 hours? What do we have? What would I do here? Good. Hala has it. Anaya has it. Beautiful. Jenny has it. Beautiful. Yeah, it would be 264 miles. How did I do that? Well, I simply multiplied 88 times 3, because if I'm going 88 miles per hour, so in 1 hour I'm going 88 miles, and if I travel 3 hours, then I will just multiply 88 times 3. Okay, 88 times 3. So I want you to go ahead and just kind of take this, absorb it a little bit. If you don't quite understand it, we're going to go ahead and talk a little bit more about this in the next couple of slides. So when we talk about motion describes how an object moves from one position to another. Okay, if I go ahead and I stand up, obviously I am now doing motion. I'm moving from one position to another. If I go ahead and stand up and I move to the side over here or to the other side, then obviously I'm changing positions. I am in motion. Okay. Now speed, on the other hand, is how fast an object changes that position, how fast it is moving. Now if I went ahead and went like this, am I going fast or am I going slow? Am I going fast or slow? Yeah, I'm going pretty slow. Now, if I was to run, let's say I was to run across my living room there, then that would be hopefully pretty fast. Now, I know I'd probably be a little slow, but that would be my speed. Speed is at a rate at which an object covers a certain distance. Okay, I covered a distance. Even though it was just a step, I covered a distance, and it was a pretty slow speed. It's measured in distance per time, MPS, okay, or MS. Now, it is always meters per second in what we call it, or MPH, when you talk about a car, but it's meters per second. The direction does not matter when we're talking about speed. I can go backwards, I can go forwards, I can go sideways, I can go the other side. Direction doesn't matter in speed, okay? Now, what does matter is when we talk about velocity. Velocity has to deal with speed and direction. Speed with direction. So if I go 3 meters per second to the right, it would be positive. If I moved 3 meters per second to the left, it would be a negative number. Now, how do I know if it's positive or negative? Well, I'm going to give you this graphic in just a minute, but I want you to take away that motion is the object moving from one position to another. Speed is how fast I'm moving. But velocity, on the other hand, has to do with speed and what direction I'm going. okay? Am I moving forward? Am I moving backwards? Okay, that is velocity. Now let's go ahead and break this down just a little bit more. So I'm going to go ahead and give you your whiteboard tools. I think they're already up here. I want you to take the line tool. And even though we talked about motion, speed, and velocity, I want you to match the definition with the term. Okay, so I'm going to want you to match the definition with the term. I'm going to give you about 10 seconds to do so. And then we'll jump back together. All right, so let's go ahead and, whoa, look at it. I love it. Yes, it's like the taste of the rainbow here. The Skittles, it's so awesome. Love your participation. So let's go ahead and take a look. So far, we're doing a really good job. So motion, and I'm going to go ahead and pop it over to this screen. Nice job. This is going to be the answer to number 2. So as I describe it, I want you to lock in your answers for number 2. So motion is described as how the object moves from one position to the other. Just how I, stepped up and I moved, that's motion. Okay, doesn't matter. I'm going from one position to the next. I'm like dancing over here. Speed is how fast you are moving. Okay, how fast, describing how the object moves from one position to another, or how fast the object changes that position, like 3 meters per second. Velocity has to deal with both speed and direction. So if I was to move to the right, it would be a positive 3 meters per second. If I was to move to the left, it would be a negative 3 meters per second, okay? I know. If anybody saw me, I'm sure my neighbors are probably thinking, what is she doing right now? Oh, well. They already think I'm crazy. All right, so go ahead and lock in your answers to number 2. I'm going to give you 25 seconds to do so. 25 seconds up on the clock. Go, go, go. All righty, so let's go ahead. Let's see. No, it's all right. Autumn, no, I think you're good. No, I think you're good. Go ahead and let me get you those notes there, Autumn. Here. There you go, just in case. I hear you. I'm tired too. All right, so let's go ahead and just check in with a few people. So Yamalet, let me see, Peter, Mickey, Mario, Luis, Cantoya, Jenny, Gabriel, Carly, Braden. Go ahead and raise your hands. I see a lot of people. Alberto, Anaya, Austin. Let's see, Braden, Gabriel, Cantoya, Kenyan, Luis, Mario, and Mickey. Go ahead and raise those hands up. Nice job, everybody. Let's go ahead and move on here. I got 20 million things going on. All right. Boop. All right, so now we're going to actually talk about velocity. This is going to be our first calculations here in physics. Now, to calculate velocity, you need two things. We need displacement and the amount of time. Well, another word for displacement is direction, okay? Another word for it would be distance is another good word, okay? So I'm going to go ahead and in parentheses put distance next to displacement, okay? Displacement is a big word and kind of a fancy word, but it just means the same thing as distance. So you need distance and you need time. Now, in order to figure out velocity, remember that the units for velocity are always going to be meters per second, okay? When we talk about distance, our unit is going to be meters, and our time is always going to be seconds. Now, I will tell you a hint here in physics. When we are doing calculations, if you know your units, everything else will become easy. You don't have to worry about the numbers. You don't have to worry about anything. If you know your units, you know how to do everything else, okay? Now, like I said, displacement is technically the shortest length from A to B, but for us, it's usually synonymous with distance. That's why we just say it's distance. So if you hear me say, what is the distance? You're going to look for the meters, okay? So look at that. Now, the formula for velocity is delta x over delta t. You might think, Mrs. Sepulveda, what is this chaos? What it's simply saying is that it's distance over here, distance over time. So if I do this, over time. That's all it is. Now, we have heard of fractions, and some of us may go, oh, Mrs. Sepulveda, I don't do fractions. I'm going to tell you right now, fractions are simply a division problem. That's all they are. And so you're going to see a lot of fractions here in physics, but I'm going to walk you right through it, so don't worry. But really, this is what this fancy equation is telling me. It's just distance over time. That's it. It's just telling me distance over time. So let's put this into some practice here. So before we do that, I want you to go ahead and put into your notes. Let me go ahead and lower your hands. Let me put you have you put into your notes number 3 and number 4. Number 3 is to calculate. Number 4 is displacement. Okay, I'm going to give everybody 45 seconds. Raise your hand when you are finished. 45 seconds up on the clock. Go, go, go. 16 more seconds. 16 more seconds. All right. Let's go ahead and just check in with a few people. Looks like we got a lot of people in here. Mickey, Mario, Luis, Kenyan, Kentoya, Jenny, Gabriel, and thanks, Jenny. I saw you popping up. Braden, awesome. Gabriel, awesome. Austin, Autumn, go ahead and raise your hand. Perfect. So Mickey, Mario, Luis, Kenyan, Kentoya, and Autumn. Raise your hand. Thank you so much, everybody else. Nice work. Beautiful. All right, let's go ahead and move on. Nice job, everybody. And let's practice a little bit. Now, you know me and my sloths. I love sloths. If you've taken biology, then you will know that, if you've taken biology with Mrs. McFadden, then you will know that she shows sloths. Well, I'm absolutely in love with sloths, so let's talk about what the sloth's velocity is. Now, I'm going to go ahead and if anybody, and I'm just going to shout out here if you want to. I want to kind of open it up. Let's do a little bit of reading here. If anybody would like to read the problem in the red box, go ahead and raise your hand. Would anybody like to read the problem in the red box? Just raise your hand. Awesome. Johnny, I'm going to go ahead and put you on live, and then I'm going to have you go ahead and read here. Oops. There we go. If I can do this, come on. All right, Johnny, go ahead.
A sloth walks to the right for 1.5 meters in 3.6 seconds. What is the sloth's velocity?
Yeah, good. Awesome. Nice job, Johnny. Give Johnny a round of applause. Let's woo! Round of applause for Johnny. High five to you. Nice job. Give him a shout out. That is awesome. Love it. Good job. Yeah, absolutely. So we're going to talk about how a sloth walks to the right for 1.5 meters in 3.6 seconds. So what is that velocity? So let's see what we are solving for. We know we're solving for that velocity, right? So let's go ahead and put velocity in there. Velocity. Okay, excellent. So now this is where it comes into know your units. Know your units. 1.5 meters. Am I going to be dealing with distance or am I dealing with time? Look at what the unit is, meters. And then look down here. Am I dealing with distance or time? Remember, displacement is distance. Good, Anaya. Good. Excellent. Am I dealing with distance or time for meters? So we're going to annotate this together. 1.5 meters is the good, Johnny. Yes, Hala. Awesome. Let's go ahead and get some more answers up there. Good, good. Let's get some more people up there. All right. Well, I think we all kind of are in agreement here. 1.5 meters is going to be the distance. And how I knew it was going to be the distance is because I looked at the units. Again, if you know your units, you're going to be good. All right. Now, so let's take a look at 3.6 seconds. So this is going to be my distance. And 3.6 seconds. What's that going to be? Is that going to be my time or is it going to be my distance? Good. Yes, Akare. Yes, Johnny and Hala. Yes, beautiful. That's going to be my time. And so what I'm doing right here is I'm annotating. So again, we might not have something like this where we're going to have it nice and pretty like this, but I will annotate it like this for you. But it's having to deal with my time. It's going to have to deal with my time. So let's go ahead and plug in my numbers. Now that I know what I have here, all I have to do now is plug in my numbers. Remember that delta x just means distance, okay? Here is that symbol for it right here. Okay, so it just means the distance. And so I'm going to put my distance of 1.5 meters on top. Okay, I want to go ahead and make sure I carry my units so that it's good practice. And then on the bottom is going to be my time. So my time would be 3.6 seconds. Okay, 3.6 seconds. Now, I'm going to go ahead and take my handy dandy calculator, wherever it may be. I'm going to take my handy dandy calculator and I'm going to plug in 1.5. 1.5, push the division sign and put 3.6 seconds. What do I get? Ooh, I'm seeing it pop up there. Yes, Anaya, you got an answer. Give me some answers. I love answers in this house. Give me some answers. Give me some answers. Woo, Johnny's up on the board. Yep, good job. Akare's up on the board. Hala's up on the board. I love it. Give me some fresh names up there. I want some fresh names up there. Let's get some answers up there. I like lots of answers here. Good. Angelina's up on there. I agree with each and every one of you. Yes, it is going to be 0.141. Now, I have 0.42 here. The reason why I have 0.42 here is if you look at your calculator, how many of you saw this nice big number like this? And I'm going to go ahead and put it at the very top. I have 0.41666666 and some other change. How many of you saw that? Give me a green check if you saw that. Oops. Give me a green check if you saw that. Yep. Perfect. Yep. Excellent. Yep. I think a lot of us, yeah. So what we do on that particular issue is I round up. So if you look right here, I have that 6. Remember rounding in math, anything greater than 5, I move it to the next number. So if I look here, 6 is going to be greater than 5. 5 or greater, I move up. So since 6 is greater than 5, I'm going to go ahead and move up that 1 to a 2. Okay, so I'm just going to simply round right here. So my answer is 0.42 meters per second. Yep, good, Amy. Yep, absolutely. Now, I'm going to go ahead and show you how to put this into our notes because this is kind of the first time we're going to do this, and we're going to be doing this a lot, and so I want to show everybody how this is done. So let me grab my notes here, and then I'm going to screen share with you really fast on how to do that. Okay, boom. All right, let me screen share. I just had to get my notes up. I tell you all to get your notes up, and then that takes me forever to get mine. Okay. So looking at here, I'm going to go down to number 5. Okay, we're down here at number 5. Now, number 5, you have the answer box. That answer box is always going to be for your number. So our number is 0.42, right? Now, our units, on the other hand, are going to be meters dash S. So M dash S are going to be our units. Okay, so your notes should look like this. I'm going to give everybody about 25 seconds to get their numbers in. I'm going to keep that up so everybody can see it. And once you have that in, go ahead and rate. Alrighty, so let me just check in with a few people here. Alberto, Alexis, Austin, Autumn, Braden, Gabriel, Jenny, Kentoya, Mario, Mickey, and Peter. Make sure you go ahead and raise your hand. Sometimes we just kind of forget, and that's all right. So Alberto, Austin, Autumn, Gabriel, Kentoya, and Mario, make sure you raise your hand. Absolutely. All right, nice job, Alberto. So let's go ahead and stop screen sharing and jump back to our problem here. All right, now that I know my velocity of 0.42 meters per second, I want to go ahead and take a look at this portion of it. Well, in our problem, Johnny said he moved to the right, right? He moved to the right. Well, if I go here, when we talk about velocity, direction makes a big difference. So again, if I'm moving to the right, my number is going to be positive. So here's a great little graphic. And if you need to take a screenshot of it, take a picture of it on your phone, whatever. But I'm going to actually put this up in our announcements tab because I think it's a great little graphic for everybody, especially when we're working in Unit 2 and talking about velocity. If you're moving forward or right, your answer is going to be positive. If you're moving up, your answer is going to be positive. But if I'm going down, anytime my problem says down or left backwards, I'm going to have a negative number, right? Okay. So now if I would to change directions, if my sloth was going to be walking to the left, what would my number be? If my sloth decided to turn around and go this way, what would my number be? Good, Anaya. Good, Hala. Yes. My number would be what? I see answers cannot. Kenyon, yes. Johnny, it would be negative. It would be negative. Kind of the same lines as, have you ever seen a number line like this? If you look at these number lines right here, you notice that if you go to the right, everything's positive. But if I go backwards after 0, everything is negative. So kind of think of that way. Again, this graphic is going to help you out so much in class. So I may put that up in our announcements tab to help you out in class, okay? So let's go ahead, and here is it's a bigger version of that graphic here. Again, right forward, up is going to be positive, so this is going to be a positive. Okay, I'm going to circle it. Over here, if you look right here, anything like that, down, left, backwards is going to be a negative number. Okay, negative number. All right, so let's go ahead and take a look at this next problem. All right, anybody like to, a different person like to volunteer to read this problem here in our class? Anybody? If you do, raise your hand. All right, Anaya, let me go ahead and make you live. All right. Go ahead, Naya.
A car travels forward 13 meters in 2.7 seconds. What is the velocity?
Awesome. Nice job. Give Anaya a round of applause. Round of applause for Anaya. Nice job. All right, so let's go ahead and take a look at this one. Good job. So a car travels forwards. Well, if I go back to this graphic here, forward, am I going to have a positive or negative number? Automatically, am I going to have a positive or negative number? If I'm going forward, yep, I'm going to have a positive number. Perfect. I'm going to have a positive number. Absolutely. So let's annotate this a little bit. So 13 meters. Again, I'm going to ask you, is this going to be distance or is it going to be time? Look at my units, meters. Is it going to be my distance or is it going to be my time? Good. Yep. Good, Hala. Good, Akare. Yes. Good, Johnny. I love it. So it's going to be my distance. Okay. Beautiful. Now let's take a look and let me grab this. I always like to annotate it up here also. I'm going to just annotate it as a big D. I don't know why it's like that. 2.7 seconds. Ooh, seconds. Is that going to be my distance or my time? Look at the units. Yeah, good. Absolutely, that's going to be my time. I'm going to go ahead and just put time right here. All right, so it's going to be my time. Now I have both things I need for my problem. I have my distance and I have my time. I can solve this right away. What goes on top here? Does anybody remember? Is it going to be my distance or is it going to be my time? What number goes on top there? Good, Anaya. Good, Johnny. Good, Akare. Yes, Hala. Yes, it's going to be my distance. So I'm going to put 13 meters on top. Okay. Now, on the bottom, what is going to be my time? Give me the number. What's going to be my time? Good, Johnny. Yes, Hala. Good, Anaya. I think you were going to be 2.7. I get it. Yeah, good, Akare. Yes, 2.7. 2.7 seconds. So with that being said, let's go ahead and take our calculator. Wherever your calculator is, good old pink calci will come out here. And so I'm going to go ahead and put 13. I'm going to push the division sign and put 2.7. What answer do I get? Good, Jenny. Yes. Yes, yes, beautiful answers. I agree with 100% of you. It is going to be 4.8 meters per second. Now, you may say, well, Mrs. Sepulveda, what about that last one? Now, if you look at your calculator, and I'm going to go ahead and put it up here, 4.8148 and some change, 14, it keeps going. Well, again, if you look at right here, I have 4.8. I have that 1 right there. That 1 is telling me I'm going to keep that 8. I'm going to round, so I'm going to keep that 8 right there. So I just leave it alone. I have 4.8 meters per second. I'm going to give everybody 25 seconds to go ahead and get your answers in. I'll show you how to do that on your answer on your quiz. Give me a quick second to screen share with you. There we go. And so I'm going to go down to number 6 here. Remember, we have one of those boxes again. So I'm going to put 4.8 here. And then I'm going to go ahead and put MS, M/S for meters per second. 25 seconds up on the clock. Go, go, go. All righty. Nice job, everybody. Let's go ahead and bring it back here. All right. So we're going to go ahead and move on. Because of time, I'm not going to call in on people. Just make sure that you're with us and that you are going understand what's going on. All right. Let's go ahead and look at the next one here. So we're going to box the correct answer. I'm going to read this one because of time, but you all are doing an awesome job. A bird dives down 42 meters in 1.9 seconds. What is its velocity? First of all, let's annotate this. Looking at here, 42 meters. Is 42 meters going to be my distance or my time? Distance or my time? Good. Yep, Anaya, good, Hala. Yep, that's going to be my distance, so I'm going to go ahead and do a D right here, okay? Now, looking at 1.9 seconds, is this going to be my time or distance? Kind of a trick question, not really a trick question. Good, Brayden, I see you up there. Yep, it's going to be my time. So now I have 2 things. But let's go ahead and box down. Looking at down, is my answer going to be positive or negative? I'm going down. Good, Hala. Yes, Anaya. Because if you look right here, down is going to be negative. Good, Brayden. Awesome. All right, so with that being known, I'm going to go ahead and put 42 on top here. Remember, I put my distance on top, 42 meters. And then I'm going to put 1.9 seconds on the bottom. Okay. What answer do I get? What answer do I get? Yes, yes, good, good. Yes, Angelina, be careful. Remember, I'm going down, so am I going to have a positive or negative? We've already kind of answered it. It's going to be a negative answer. Yes, good, Angelina. Good correction. All right, beautiful. Yeah, so my answer is going to be a negative 22.1 meters per second. I feel like we have a good understanding on how to put it into your notes. Good, Johnny. So I was just putting that. Yeah, no worries. So go ahead and lock your answers in. I'm going to give you 25 seconds up on the clock. Remember, the number goes into the answers box. The unit goes into the units box. 25 seconds up on the clock. Go ahead and raise your hand. Go, go, go. We have one more. Thanks for hanging in there, everybody. Thanks for hanging in there. Usually these lessons are a little hard because of the math. All right, 4 seconds, 4 seconds. All right, perfect. Nice job, everybody. I am super proud of you today. All right, so let's go ahead and jump into our last question. This one's our complete on your own, but I'm going to go ahead and break it down with you. So a firebolt can travel forwards across a 500-meter long Quidditch pitch in 8 seconds. What is its firebolt's velocity? First of all, 500 meters, is that my distance or time? Yeah, good. I'm seeing it up there. Perfect. Yep, it's going to be my distance. Perfect. What about 8 seconds? 8 seconds. Looking at my units. Yep, I got it. It's going to be my time. I see it popping up in the chat box. Now, I want everybody to look here. 4 words. Am I going to have a positive or negative answer? I'm going to have a positive answer, so I'm going to have 500 meters up here, 500 up here. I'm going to have it over 8 seconds. What is my answer? Go ahead and do this. Complete this one on your own. If you want to check with your answers in your question and answers box, go right ahead. At that point, if you feel good, you can go ahead and submit your notes. Have a wonderful weekend. I am super proud of you, period 4, for jumping up there and just kind of working with me, and just have a great weekend. We'll see you back here on Monday. Bye now, everybody.